All right, welcome to your second lecture. So hopefully you had time to not only enjoy and take in the information from lecture one, but also hopefully you got introduced to the labs. So and got to meet our wonderful studio artists, Sarah and Wade. With that said, let's go ahead and get the show on the road. So like a couple announcements before we go. So one, if you're still having issues with your software, which if you joined a little bit earlier, you probably heard a couple people are having issues with their software. You want to make sure that you're going to today's lab to try to get that rectified as soon as possible, because the thing is that everybody is aware that spring break is next week, right? Hopefully everybody is aware of that. So with that said, realize that also spring break is a lot of the vacation times for a lot of our instructors. So you may not get that much or if any assistance at all next week, which I'm not gonna put the announcement out, just kind of warn everybody. That is why we don't have any deadlines during the spring break portion, because we're not going to expect you to work and get assignments done during a time where there's no support at all. So we want to make sure that you're at least getting one final lab in before you get your assignments in. Now, as far as assignments, make sure that you are aware that all your lecture activities and your competencies are due on Monday by 11:59 p.m. on the 12th. So you will have an entire, week off. Enjoy it, get as much as you can out of it, because I think that is the last huge break until the holidays. So now let's see. I think that is about it. So let's go ahead and start talking about our today's content. So on Wednesday, we went over the concepts of the 3D environment. We introduced you to both Maya and Unreal. There we go. A little bit easier to see. We introduced you to Maya Unreal. We showed you not only how you can move yourself around, which is when we move around the cameras, but we also showed you how we can move around objects using translate, rotate, and scale. With that concept, we took you through like the idea of stacking, building dioramas, and then finally leaving you with the potato head. Now, how many people got the potato head done? All right. Couple people it looks like. Again, good rule of thumb, if you want to kind of keep on track, all you want to do is just make sure that you have the prior week's prior lecture activities done before the next lecture. And if you kind of keep that kind of goal going, that will keep you on track. Now, keep in mind also you will have competencies outside those lecture activities. But with that said, let's go ahead and introduce our building block of what we're going to be building with for our pretty much month degree program and probably your entire career, which is the concept of polygon. So what is a polygon? Polygon is essentially a shape. Anything that has 3 or more sides is considered a polygon. Now, we choose to build with these right here. That is the base level of objects that we actually build with. When we create cars, when we create humans, all it is us taking a bunch of shapes and manipulating them, bend them around, and adding more and more until we get what perceives to be a car, a human, anything like that right there. Now, it is our preferred method because nowadays, back in the day, polygons were a little bit harder to render. So we used to use a technique called NURBS, NURBS, that stands for non-uniform rational spine. I'm sure Brian's going to write the right phrase for that down. But essentially what NURBS was essentially taking a piece of cloth and somehow bending it into the shape that you need to be. And the thing is that it produced really nice curved surfaces, but it did not lead way to a lot of intuitive ways of manipulating it. Meanwhile, polygons, you move around polygon, you move it around. You don't have to worry about like adjusting stuff. But nowadays, since the added benefit of processing and memory and all our computer know-how, we are now able to pretty much have limitless polygons. Now, with that said, let's go right here and start talking about the different parts of our polygons. I wonder why that camera is still on. So if you can, go ahead and make sure that your camera is turned off. But let's go ahead and load up my amazing polygons. So file, open. And if you notice already that I'm currently on Windows, I will be switching back and forth between Windows and Mac just to show that there is not really that much of a difference between them. But let's go right here to my documents. My documents already has a 3DF folder. We're gonna go right here to week 1, and then I'm gonna load up my lecture 2, and we're gonna grab that amazing Polygon file. Now, we're gonna have 2 files today that are only gonna be on my computer, and they're really just going to show you what's going on with our polygons and eventually problem geometry. But don't worry about them. You're not going to need these for Turnitin. Now, with that said, let's talk about the amazing polygons. So when we talk about polygons, we're talking about these 2 base shapes, which is our main form of construction. So first we have triangles, or what we lovingly call tris, which is our most basic shape. And this right here is when we go to render, everything becomes a polygon. When everything goes into a game engine, everything becomes a polygon. That's because it goes through a process called tessellation. Tessellation is where everything gets subdivided to their most simplest basic forms. They're easier to calculate, and they're easier to render and put in real time. But they are not our more preferred way of building. You're probably going like, why? If it's the most basic shape and that everything becomes a triangle, why don't we just model with triangles? Well, it comes down to how we use our tools and how Maya sees our surface. With a triangle, for us to use certain tools, it needs to see the surface direction. And for a triangle, where's top? Where's bottom? Where's left and right? And the thing is that we could probably pick 3 of those, but we lose that 4th one. And that 4th one prevents us from using a lot of tools on them. Meanwhile, the preferred method, which is lovingly called quads, Q-U-A-D, quads, is our more preferred way of building stuff. When we actually build a car, when we build a human, we build them out of like over and over repeating quads, which is 4-sided faces. And the reason for that is, 1, when it goes to tessellate, it tessellates cleanly. All a quad can be is 2 triangles. You draw them straight down the corner and you're good. But another added benefit is the notion of surface direction. When we use tools, when we actually make selections, Maya can see that there is a top. So if it enters in from the top, it can go down to the bottom, and vice versa from the left to the right. So adding in that little extra edge adds in the fact that we now have some kind of surface direction. Now, with that said, we do have one other component that we will be talking about, which is, let me go right here and create a polygon, which is this beast right here. This is what we lovingly call an n-gon. Now, we will go more into this a little bit later, but this is pretty much represents anything that is over that 4-sided face, that quad. So pretty much we have triangles, our most basic shape, which is what everything begins as and ends as. Then we have quads, our preferred way of modeling. Now, I'm not saying that you can't have triangles in your stuff. Triangles are fine. We just want to make sure that we're not putting them in areas where they can cause havoc or prevent us from using certain tools. But then we have this right here, which pretty much is the surface that is anything over that 4-sided face. And that's where everything gets really, really wonky, because not only do we not have surface direction, but also Maya doesn't know really how to tessellate this or turn it into a bunch of triangles. Now, this right here are triangles and our quads, but let's go ahead and get a new surface in here. And let's start talking about the anatomy of our object. So first, when we select on something, the only mode that we've been in is something called object mode. Object mode. This is where it's the whole kit and caboodle. If it's connected to it, when I select it in object mode, the whole thing comes in or comes with it for the ride. That's our first part. That is object. Now, let's start drilling down into the different areas of effects and the different components that make up our object. So first, to change between our different modes, we go right here and right click. And when we right click on the object, first, notice that we get different menus based off of where we're at. That's because Maya is very contextual based. That means it looks at where your cursor's at, what you have selected, and all these different options to give you different menus. That's the whole idea of Maya, is that it can wrap in a whole bunch of complex menus behind certain actions. So that way we can quickly get to where we need to be. It goes into that whole notion of giving us several different options, and we pick which one is quicker for us. So if I select this, not only do I have it as my active selection since it's green, but now I have it also selected in object mode. If I want to go to the next level down, we can right click and we get all our different modes. Now, some of these are key component modes, and some of these are hybrid modes. And some of these are also different dimensional modes, which we'll talk about UVs next week. Actually, I'm lying, in 2 weeks. All right, so with that said, our first level below object mode is face mode. Face mode. Face mode is our enclosed surface. So we got right there, we select that face. It is a surface that is enclosed by the other components. Next, we have edge mode. If I right click, I go to edge, then I can select an edge, which is the line between 2 points or 2 main factors. So we had our face that's enclosed by 4 edges. And then we have our edge right here that is hooked between 2 points. And then lastly, our smallest increment of influence is right here. If we go right click, we can go to vertex mode. Vertex mode is our smallest point. It is literally one single point in 3D space. It has X, Y, and Z, and that's about it. Now, when we think about these components, we want to think about it as almost a upside down triangle. At the very top is object mode. Below that is face. Below that is edge. And below that is vertex. As we go down that triangle, we get to smaller and smaller levels of effect. Now, this is important. No, because again, there's limitations on what we can do in each one of these modes. And being able to go down deeper allows us to get smaller and smaller details. That's how we can take something that was a cube and eventually turn it into a car. We couldn't just take that cube and use translate, rotate, scale on it to form that. Instead, we had to go deeper and deeper and deeper. Now, those are our different components. So essentially, we go right here. When I select an object and I move it, I move around the entire object. If I go right here and select the face, I select the face, and not only do I move that face, but I also move around the 4 edges that make up the face and the 4 points that connect up those edges. Next, if I go right here and move around that edge, when I move around the edge, not only do I move the edge, but to the 2 verts that are connected to it. And then finally, if I select 1 vert, then I can only move around that vert. Now, it sounds like I'm probably just rehashing the same thing I just talked about. But the key thing to take from this is if I can make a selection or make a movement on one component, I can do it with any of the ones below it. So if I can make a modification with a face, then that means I can also do it with the edges instead. And then likewise, I can also do it with the verts. Meanwhile, if I can only make that movement with the edge, then face is out of the equation because now it's above the edge mode. Now, with that said, that is part of our components. Now let's talk about a couple other key things that we have to keep in mind, which is if we go right here, I'm going to create me a sphere. Yeah. All right, so first, we have an edge, but there's another thing that we have to take in consideration with our edges, which is what do we refer to them when they're in groups, and specifically a certain style of groups. So first, if I select this edge, that is an edge by itself. But if I double click on it, it will select all the edges that are connected to it in succession all the way around until it hits either itself or an obstacle to end what we call an edge loop. This is an edge loop. Reason why these are important is because they are the foundation of the surface direction on our object. This is how we can channel and control our tools and how we do detail. This will become more important on week 3 when we start talking about edge flow and how we flow those details. So that is an edge loop. Next, if we select an edge and then hold down Shift and double click the one next to it, we will get the edge ring, which is a order of parallel edges to each other that go around a surface. So we got the edge ring. Now, this can go by a couple different names. First, we have edge ring. Other people call it an edge channel, because if we put another edge loop in there, it will follow that channel, that stream all the way around, because essentially all we're doing is picking the surface direction. So if I enter in this side, it's going to exit out this side, and we keep on doing that ad nauseum all the way around. So that's edge channel, edge ring. The last thing that we're going to also call it is if we hold down Control. If you're on Mac, it's Command. This is one of the few times that this changes. We can bring up another context menu. And this one right here is our selection type menu. So if I'm holding down on Windows, I can hold down Control, right click. And one of the cool things I can do is go right here and just change this to face. Now, if you're on Mac, it is Command right click. But this is the last thing that we're going to refer to this as, which this is called a face ring or a face loop. They're interchangeable. But the key thing is that how these form a train track around our object, how they flow around our object, are the core principles of how we will start building our objects and how we can make our tools and what we do predictable. So again, right click, but not holding down anything. We can go right here, change it to the different modes. If we hold down Control, right click, we can change this to different types of selections. Now this right here is kind of helpful. But another way is our different forms of doing selections. So I'm gonna go right here, make a couple of these. All right, so before we talk about our last component that makes up a polygon, let's talk about different ways of selection. This is important too, since we already introduced the selection menu. So everybody already knows the one way to select everything. You just point, click on it, it gets selected. Or we can marquee select and it gets selected as well too. Now, how many people have started doing shift select? You hold down shift, you select another thing and you can add to your selection. How many people have done that? All right, so let's refer to shift select, which is if I hold down shift and select another object, it gets selected. But if it's already selected with shift held down, when I click it again, it gets deselected. That's because shift is a toggle select. A toggle select. Next is if you hold down Control Shift and select, this is what we call an additive selection, which means it will never deselect, it will only add to our selection. Lastly is holding down Control Select. Control Select will only deselect, it will never select. This is important because this will speed up our workflow. Let's say I want to get a couple edge loops right here. First, I can either double click on the edge to select the edge loop. I can hold down, click one edge, and then hold down shift and double click the edge next to it. That will add to it. But let's say I want to get some vertexes at the top. Instead of me going around and clicking these on one by one, instead I can be a little bit haphazard and just kind of select like so, and then go around and make any, well, I actually did that correct. All right, so let me go ahead and kind of do that right there. And then with that selection made, I can use control to start removing from the selection as needed and using my hotkeys to fine tune that a little bit more. And now you get that. All right, so that's a little aside right there to kind of show you different techniques to kind of speed stuff up. But the last thing that we're going to talk about on our polygons is its direction that it faces. So yes, back in the day, especially when 3D was first coming to video games, they used to always like scream and cry about like, like, hey, we could do this many polygons a second or this many polygons per second. And you probably noticed that steadily as we got newer and newer consoles, they kind of stopped saying stuff about polygons. That's because now they're so cheap, so easy to render. But one of the reasons why they're so easy to render is because normals only have, our polygon only faces one way. It's only displayed one way. And that is referred to as its normal. Normal. And if we go right here, I'm going to go to display, polygons, and I'm going to turn on face normals. Now you don't need to do that because I will turn this off once I prove the point. But the fact is if we look right here, we have this little green peg that sticks out right there. That is letting us know that that normal is facing this way. Now you're probably going like, okay, cool. What does it look like on the back? Well, it's black. Not because that color is black. It's because polygons only get lit. They only receive light on one side. So the back, since it's not receiving light, is black. Now, Maya is doing that to help you out. When in fact, what it really looks like, and if we bring this into any of our other programs, this is what it really looks like. If I go right here to shading, turn on backface culling, that is what it actually looks like when we bring it into Unreal or bring it into Substance Painter or any of the other programs where they do not try to do us a favor by showing us both sides. Instead, it just does not render it. So if I turn around, there's a polygon. But then if I look this way right here, we can see that it disappears. Any questions so far? All right, so that's the key thing right there. Polygons, we have two main ways of building. We have triangles, we have quads. Everything at the end of the day becomes triangles, and they're okay to build with. But the preferred method is quads. Quads allow us to not only control our surface, but also control our tools. And it makes sense to Maya. Like we have a couple of different tools, several different tools that require on that surface direction, up, down, left, right. And then we have normals, which is the main way that it faces. Now, with that said, not everything is all fine and dandy in the polygon world. So let's go right here and load up problem geometry. Make sure I'm hitting all my points. Yeah, there we go. All right, so let's talk about problem geometry. So not everything is perfect inside our geometry world. That's where we need to start talking about problem geometry. When you go to build, a lot of things is that Maya lets you build anything. It doesn't care. It will let you pretty much make a mess and then just hopes that you go back and fix that. And that mess is referred to by different names, but it all is considered problem geometry. Now, we do have some that are a little bit more troublesome than problems, but problem geometry essentially is geometry that will break our stuff. And by stuff, I mean, for you, break your ability to use tools, break your ability to use selections, break your ability to do UVs, which we'll teach you about UVs. But it goes beyond that. It actually trickles through the whole entire production pipeline. It will prevent you from properly rigging it, properly animating it, properly shading it, properly rendering it, properly bringing it into a game engine. It will screw up your day and production. They're serious business. Now, first, let's go ahead and introduce the troublesome geometry. Now, this right here, you're not going to be expected to memorize these and know how to fix these just yet. We're just putting this on your plate to say, hey, you know, be aware of this. We're going to be revisiting this several times throughout the month. Now, the first ones that we're going to talk about is troublesome geometry. We have these three, which is non-planar faces, concave faces, and convex faces. And the reason why these are troublesome is because 9 times out of 10, since we're still technically lower to mid-range modeling, which means we're not doing anything remotely high res or high resolution, which means more and more poly count. When we are doing that medium to low res, we're going to kind of stretch our polygons a little bit right there so we can get our forms. And the thing is that some of these will actually pop up, but unless they're severe, we typically do not worry about them. But we have to be aware of what looks bad and what is bad and why it is bad. So first, we have non-planar faces. Non-planar faces is essentially a polygon face that pretty much all its verts are not on the same plane of existence. So if we look right here, we got 3 right here, and then we have 1 all the way off to the side. And that can cause some major issues because right now, if we look, we're getting a break in our polygon. We're getting a break in there. And the thing is that we can't physically have that break there because there is no edge there to break it. Maya is thinking that it's doing us a favor and breaking it for us. The problem is that Maya makes this decision on the fly. And it does that every time we render, which means one time we look at, it may look like this. And don't worry about what I'm just doing right here. But one time it may break it like this for rendering when it does the tessellation process. Or next time it may break it this way. And you're probably asking, what is this next time? Well, it's every frame that Maya makes this decision. And if you remember, how many frames are in a second of animation? 24, depending on that 24 to 30 frames per second. And how many seconds in a minute, how many minutes in the movie, so on and so on. So you can see how having this right here and having that decision pop back and forth over and over again can cause something called flickering, which it just looks like your geometry is just popping in and out. If you remember back in the day when you played PlayStation games and it looked like the walls kind of like popped in and out, one of the reasons for that was 1, how they handled textures, and 2, the lower poly counts and how it was being drawn would cause that. Same way with video games, depending on like what video game you're playing, it could be anywhere from like 30 frames per second to nowadays it's going to 144 to 240 frames per second. So you can see how that flickering could like go insane. Now, the reason why it's troublesome is while this obviously needs to be fixed because we have a very big break, something like that right there, that's just slightly off, that's perfectly fine. But Maya still considers that a non-planar face. So we're not going to worry too much about that. Only when they're extreme do we go back and fix them. Same way with these 2 right here. Essentially, this one right here, a concave face, where we have 1 point going into the surface area of our polygon face. Think of this as if I took a handkerchief and pinned down 3 corners of that handkerchief and then slid that 4th one into the center. what happens to that handkerchief? It starts bunching up as I slide more and more into its area. Same way here. Occasionally, it'll give us that V shape, and sometimes it will actually take the excess of that polygon and kind of like shoot it off to the side, almost as if we folded it over. So we have to be careful about that. Last but not least is convex, where we have pretty much all our vertexes kind of uniformly there, except for one is way off to the side. And there's one thing our 3D programs like, and actually most computer programs in general, they like stuff to be uniform. They like stuff to be kind of evenly spaced. So when we have three verts that are really kind of nicely laid out and then one just kind of off to the side, crazy like that, that can cause issues when it comes to giving that object texture area and showing and displaying images on it. Now, like I said, these are more the troublesome ones. Unless they're extreme, we don't really worry about fixing those. But these bad mamma jammas, they need to be fixed. So first, we have the one that we saw earlier, which is anything over 4-sided faces. Remember, we prefer 3-sided faces, but we also prefer 4, which 4-sided faces or quads is our most preferred one. But anything over that is considered an n-gon. N stands for pretty much any number of sides past 4. So if we have a 5-sided polygon, then it is a 5-sided polygon. Now, the reason why this is an issue is because of, again, that tessellation. How does it make this into different triangles? How does it calculate it out? And here's the thing. Granted, we only have one person in the room right now, but if there was 3 other people in here, I could probably hand this shape to y'all and tell it, hey, divide this into triangles. And I would probably get 4 different results. All right. And that's the same way with Maya. It may decide to like triangulate it one way and then triangulate it another way later on. So again, we always want to try to make sure that we're taking as much control back from Maya as possible, so we can make sure that our art and our work are actually meeting the standards that we are setting it up for. Next is a face with holes. So essentially, we cannot have detail without components holding that detail. What does that mean? Well, we have this hole, but there is no edges holding these holes and holding the structure. Think of this right here. Think of this as a suspension bridge. And then somebody went and cut all the cables. Maya is doing us a favor by holding that shape, but it's so fundamentally broken that Maya won't even allow us to fix it because it doesn't even know how to draw that surface anymore. It's just keeping that hole there and then praying that you eventually delete it and get rid of it. And this is where I see most students make this mistake, which is a lot of students get like the concept of being efficient with their geometry, and they get that concept wrong, which is they look at their surface and say, all right, well, you know, those edges that were holding that hole, they're not adding anything to our surface. They're not changing the silhouette or anything like that. Let me go ahead and get rid of them. But in fact, our geometry is there to do a couple things. Not only hold the silhouette and give us a whole different, like, you know, look when we are looking at details, but it's also there to hold those details to preserve the prior surfaces. And removing them can cause that issue. Next is something called lamina faces. Lamina faces is essentially one of the harder ones to kind of show. And if you notice, this is kind of me like in a lab kind of showing like very, very clean lab results. But the fact is that it's a little bit harder to kind of force this issue. But essentially, lamina faces is 2 faces that are on top of each other and they share all their edges with each other, which as far as Maya, math, and just real world is concerned, if 2 faces are sharing all their edges with each other, then essentially there's not 2 faces. There should be only 1 because they share all their same components. So at that point, they should have merged together a long time ago. But mathematically, something broken in the back end of Maya, Maya is allowing both those faces to exist. And it's creating what we like to call a geometry pizza pocket. All right, so that is lamina faces. Last but not least, non-manifold geometry. non-manifold geometry, which is essentially geometry that cannot physically exist mathematically or in the real world. A lot of this geometry can't exist, but non-manifold geometry will ruin your day because this can be like some of the worst stuff to have to clean up. And it's so bad that there is 3 different types. First, we cannot have 2 faces. Remember, faces are surfaces that are enclosed by edges. We cannot have an edge be shared by more than 2 faces. As you can see right there, we got a T-junction, which is we have 2 faces and then we extruded another set of faces out of an edge. Realize, for the most part, edges do not have mass surface area or anything like that. So pulling out new surface area, new geometry from something that is enclosed like that breaks Maya. Now, if I wanted to pull out more edges right here, since this is not an enclosed surface, that's okay. But once we have a closed surface like that, we cannot pull out more geometry. Now, we'll talk about how we pull out geometry when we get back from break, but that is our first non-manifold geometry. Second, we cannot have an edge share 2 faces that have, what is the word for which way a polygon faces? What's the word for it? Normals, exactly. So we cannot have an edge be shared by 2 faces that have opposite facing normals. That's like randomly on your arm, part of your skin decided to like flip itself inside out. I don't know if anybody remembers Nickelodeon from the 90s, the Inside Out kid that went over the swing. Anyway, yeah. So anyway, that's that concept right there. You just have like your arm, and then halfway down your arm, it decides, okay, cool, and I'll like flip to your innards. Same way here. We cannot have a surface change like that. All right, last but not least, we cannot have 2 faces be connected to each other and share no edges. And I know some of these sound like, like riddles from the labyrinth, but the fact is that yes, we cannot have 2 faces only be connected by a vertex. A vertex, remember, it's just a point in space. It's not something that connects surfaces. It needs those edges. Remember, we have that upside down triangle. We have object mode, we have face mode, we have edge mode, and then we have vertex mode. If we flip it over, we almost have like the level of dependence. We cannot have a vertex without an edge, and we cannot have edges and vertexes without faces. So that's essentially right there. We cannot have these be connected by a vert. They need edges to do that. Now, this right here is to get this kind of put in the back of your head so you can be aware that there is problem geometry. Now, I don't know if like Blender has changed. I haven't like modeled in like a while, but back in the day, they used to make their tools where it tried to prevent you from doing problem geometry. If you ever use Blender, it may have actually changed. But the fact is that Maya doesn't give 2 craps about your problem geometry. It's just like, all right, cool, do whatever you need to do as long as you go back and clean it up. And that's the thing that we have to be aware of. A lot of stuff that we're going to do is going to cause these issues. Now, it is going to be a learning process and a practicing process over years of getting good at this right here. But we still want to introduce these. So when we go back and start talking about them again, when we get back from break, you'll be aware of them. Any questions so far? So these are the holy laws, not really. One of the things that you're going to learn is that in 3D and most art programs, we'll give you laws and standards and all that stuff right there. And once you understand them, you'll start breaking them. All right. All right, so let's go right here. And I'm trying to remember which part I need to go to next. Actual problem geometry. Oh, yes. Our objects, manipulating our objects. So actually, I'm going to bring this over here so I can keep this open. So I'm going to go ahead, do new. So let's go ahead and introduce your new best friend, primitives. Primitives, which is, you got to realize that when we start building things, whether it's like Optimus Prime or Nathan Drake or the new hot new sports car for the new Fast and Furious, or for like any video games, we don't form polygons out of nothing. We're not like Thor crafting these out of like, different shapes. Instead, 9 times out of 10, we start with a primitive, which is a basic shape. So if we want to see kind of like a nice little lineup of them, right there, those are all the primitives that are available to us. These are the shapes that Maya gives us for free. By which I mean, like, if you paid your like a couple $1,000s for the program, they give you these props for free. And the key thing is that picking out the right primitive for the job can save you hours. All right. Here's the thing. Anybody who's really good at modeling could probably take these shapes and turn them into whatever. Like if I was to do a baseball, I could start with a cube if I wanted to, and then make it look like a baseball. But why? That just made me take longer than I'm supposed to. So instead, being aware of the primitives that are available to you and which one fits what you're trying to go for is important. If you haven't yet, please, where did my chat go to? There we go. So if you haven't yet, and really spend some time like just exploring Maya, but at the very least, go into create, go into polygon primitives, and where that dotted line is, go ahead and click on that. That will rip this menu off, and do yourself a favor, make every one of these, by which I mean click, look at it, and observe what it is. So we already know sphere, that's a ball. Cube, that's a block. Cylinder, cone. So these are your basic shapes that you usually are aware of. These are the ones that you've learned about since you were in pre-K. But then we also get like the oddities down here, like the platonic solid, the primitive pyramid, stuff like that. And being aware of those shapes can save you some time, wink, wink, on certain things like your competencies or anything like that. So with that said, let's start talking about our primitives. So I'm gonna go right here, delete all those. Show that right there. All right, so first, yes, where are our primitives located? Well, first we want to go into create. Anything that we can create quickly is going to be underneath this menu. And what we're going to be looking for is the polygon primitives. Now, this is important because we also have different other types of primitives. Make sure that you're staying in the polygons. Anything that is out of these different fields will not be counted. So make sure that you're in polygons. Now, let's go right here and let's make a cylinder. Now, when we create a polygon, first it will create an auto place itself at the origin. Now, what we're looking at is our cylinder or whatever primitives that we have. But we have to be aware of what we're looking at is something called default settings. So when we create this object, this isn't the only cylinder that we can actually make. Instead, it is giving us the most popular settings, which is, if I go right here to polygon primitives, open up the settings, which to get to any setting for any one of these objects or any one of the different tools that we're going to be using, when we see a box next to them, that will open up its settings. And what we're looking at is right here. When we create this without even thinking about it, it's already given us a radius of 1, which is 1 grid unit. It gives us height of 2 grid units. It gives us subdivisions of 20. So those are the different points and edges that make up our object. The higher that subdivision is, the rounder it's going to be. The lower is, the blockier it's going to be. Now, a lot of y'all are probably going like, well, this seems kind of, hard to think about. How do I plan this out? How do I make sure I pick the right one? Well, you can go in here, but let's talk about how we can affect the default settings after the fact because we like to keep it intuitive. I would like to see some visual feedback. So to do that, first, we need to select the object. And then over in our sidebar, now notice that I'm in Maya Classic right now. So if you are not in Maya Classic, you may want to switch over there. But if you don't want to, I'll show you how to get to this area right here, which is, this is our sidebar. And then underneath our workspace dropdown, we have a couple different icons. These will allow us to populate different boxes inside of this sidebar. What we're looking for is this stack of papers. The stack of papers will bring up our channel box / display layers. Now, both of these are going to be very important for different reasons. But first, let's go ahead and talk about our channel box. Our channel box is a menu set up for us that not only gives us the translate, rotate, and scale of our object. So as we move stuff around, rotate it around and scale it, it will change the numbers that will change its address inside of our 3D environment. So this can be very useful because let's say I want to turn this a quarter way around. So if I wanted this to be like exactly like this right here, but I want to make sure that I'm fine tuning it. Instead of me trying to eyeball it, let's see, what is 1/4 of 360? Well, I think it's going to be 90. So if I just type in 90, instead of me having to eyeball it and turn around, I can start plugging in numbers so I can get more accurate movements. So that is something that we'll be doing a couple times throughout this month. But that is our channel box. This is how we apply transforms. And when we actually move stuff around, this is what it's actually affecting. Its position in space, its rotation in space, its scale, all that information. Below that, we have our shapes and our inputs. Now, our inputs is how we can make different changes to our objects. Now, remember, when Maya sees our object, it doesn't see a cylinder. Instead, it sees a node. So let me go right here, hit the node editor. So this is what Maya is seeing. It's just a box with some math in it. Well, the cool thing is that we can actually affect that math through here by playing around with its inputs. So if I go with that selected, go into its input, click on polycylinder. Inside of here, there's all those settings that were in that settings box from before. But now, instead of me having to figure out all that stuff before I create it, I can do it after I create it and see it update on my object as needed. So let me go right here and change this back to 0. So let's say I wanted to make, I don't know, wink, wink, a cup. Let's kind of evaluate what needs to happen. Well, first, does it need to be bigger? Well, if I go right here to radius, I can select that and I can change it by middle mouse clicking and dragging left or right inside my viewport. By clicking this and middle mouse clicking and dragging, this will turn this into a virtual slider. So I can visually make changes to my object. So if I want to do a cup, I think that's big enough for a cup. Let's see about the height. So if I go right here to the height and start changing that, well, I can do that as well too. But I'm still kind of doing things that I can do with my scale. All right, well, what about this? Do I want to be blockier or rounder? You know what? I think I'll keep it a little bit round, so 24. But I need to have a cup, which means that it needs to have the outside and the inside. So, well, I can't just bring this down because that doesn't look like a good cup. I wouldn't want to drink out of that. So we need some more edges to kind of hold the structure and be able to change it. So if I go right here, and let's see where I can get more edges in this area. Well, I can do the height. Well, that's not where I want them. So let me go back. And then let me do, what about subdivision? And oh, there we go. So now I can go right
You're muted.
The audio went out.
Hold on just a few minutes. I'm sure he's changing his batteries in the microphone. Thank you.
So, yeah, I don't know why sometimes they'll last for like 2 weeks and sometimes like they'll die like several times. I don't know why. But anyway, going back. So let's say I wanted to make a cup. Well, I need the top and a way to make the bottom go down. So now that I add these subdivisions up at the top, I can be able to do that. So let's go right here and select some faces. So I'm going to select these. Now we have to be careful when we select, the selection goes all the way through our object, which means when I selected like that, it selected the bottom as well too. So how would I deselect these? What would be a quick way to deselect these? Hold down Control Select, exactly. So now I got the faces right here. I can now push this down. Now I'm having a hard time seeing through the skin of my object, the shaded part. So which way, how could I see through my object? What can I press to see through my object? 4, wireframe. And now I just bring that down. And then if I wanted this to be more cup-like, what should I probably do? What? Yep, just scale it out. Yep. And again, we change different modes by right-clicking on our object. So when I was done with edges, I just right-clicked and then went to face mode. And now let's go ahead and look at the depth of my object. So how do I see the skin of it? How do I see the depth of it? Hit 5. Yes, we bring up shaded mode. Was trying to not say shaded, see if I could like get y'all thinking, but yeah. And now we got a cup. Just by modifying the defaults, that gave us enough geometry, because that is a key part. For us to have any change, any detail, we need the geometry there to hold it, to preserve it, and then also to change it. So again, looking at our edges and their importance, we have this edge, right? That not only holds the top right here, but allows it to change from this side right here to that side. This edge right here not only preserves the detail of this ridge, but allows it to flow into this edge right there. We always need edges, components, to not only hold the shape, but also to change it. Now, as far as default, we have to be careful. So whenever changing these settings on our primitives, whenever we change the settings on our primitives, we have to do it at creation, which means when we create it, that's when we need to change them. That's because of something called history. When we make changes to our object, when we manipulate it, when we move a vert, Maya keeps a log. And think of it this way, go back to that node. As we're making changes, it's making a new node and then piping that information into that node. Think of it this way, it's like almost like a train with a bunch of different cars. For us to make changes, we start at the caboose and then work our way all the way through the front. And every change we do, we have to start back at the caboose and work our way through. And that means that if we make any changes and then try to go back to that caboose and manipulate it, well, it has to shoot it through the other carts first. which means as I pump this up, we will get issues because of that extra history. So if we make changes to our objects using the default settings or make changes to the settings, we have to do it when we first create it. Now, because of history. Now, one of the things that we also have to be careful about is history can be dangerous. Right now, we're keeping it simple, all right? Which is we're barely moving stuff. We're not using any tools this week or anything like that. But history can be a time bomb as we get more and more complex. That's why it's good to every now and then delete our history and then save. So to delete our history, we want to go right here, go to Edit, Delete by Type, History. And that will lock in the information and get rid of that long train of information. Our history can be explosive, so we want to occasionally delete history, and we specifically want to do it before we save. And it's so important that when we select an object, these three icons are what we also call the cardinal cleanups. This right here will delete our history. Any questions?
Yeah, I have a question. Is that okay?
What's up?
When you say about the history, once you delete the history, now you can move the cup whenever you want to, and won't mess it up.
Yep. We can move it wherever we want, and all the changes are now locked in.
Okay. All right. Cool. Thank you.
You're welcome. All right. Going to hit new. And now on to our next part right here, which is our first exercise. So I'm going to go right here. Let me go ahead and grab our first exercise, which is our snapping exercise. So I'm going to go right here. Preview. I'm going to scroll down to lesson 1. We're going to go to Introduction to Polygons, and then we're going to grab our snapping exercise. So let's go ahead and download that. I'll go right here to Show in Folder. And we're going to double click on it to expand it. I don't know why. I'll right click on this right here, Extract All. If you're on Mac, all you have to do is double click on it. And then I want to go right here and I want to copy this into my 3DF folder. So right here, week 1, we're in lecture 2. And I'm just going to Control C, copy. If you're on Mac, it's going to be Command C. And then I'm going to hit Control V, the paste, or Command V if you're on Mac. All right, so let's go right here. And you probably noticed that I've been skipping a step as I've been opening up these different projects. That's because we didn't have that central program project folder. But now let's go ahead and have a brief reminder of the proper way of opening up our project. So first, we want to make sure that we open up Maya first. So we already have Maya open. Awesome. We can always just hit new, kind of clear everything out. But now we need to set our project. So we're going to go right here, File, Open. Oh, gotta be careful. The chat window was covering up my open window. It's like, oh, where'd it go? All right, so inside of here, we need to navigate to the main directory that has the workspace mail, so we can tell whether or not a folder is the main directory, by which if we just open it up, we should see immediately the workspace mail, which is not right there. I have to actually go into the set project first. And then go to Documents, 3DF. Now to let you know, if you found your location, you set it up and you want to save yourself some clicks, as long as you know where the stuff is at, you can make bookmarks by going right here and just dragging this over. So now I have my 3DF bookmarked. And now I can go right here to week 1, lecture 2. Click on the main directory. We can tell that it's main directory because it has workspace mail in it. Select that, hit set. Now we can go right here to scenes and snapping pivots and objects. Don't save. All right. So let y'all rest your mind for a second so I can like take a drink of water. Because we got a whole bunch of new concepts to go over. So first, let's talk about what is happening when we move stuff around. So I'll go right here. I'm gonna actually copy this. And so we remember from like last lecture, and hopefully y'all remember, we have our one-dimensional movement, which is our arrows right here. We have our two-dimensional movements, which is the squares in between the arrows. And then we have our three-dimensional movement by grabbing that little open box. The thing is, with this right here, that box is something different. We're calling it the three-dimensional movement for right now because that's how we unlock all of those. But also goes by a different name, which is our pivot. Our pivot, P-I-V-O-T. And our pivot is where the action of movement is happening from. So when we are moving, rotating, or scaling, we're not scaling from the actual object center. Instead, we are rotating, moving, and scaling that object from the pivot. Now, what does that look like? Well, if I go right here, and also if you open up the scene and you get this little window right here, don't worry about that. You can just hit OK and go about your day. Now, let's say I had my pivot off to the side right here. Well, when I go to move it, not much has changed. It's still moving. It's just a little bit more cumbersome. It's off to the side. Things go wonky when we start rotating, though. When we rotate, now it's rotating around that pivot, its main point of focus. So instead of me rotating the object around its own center, instead now it's orbiting around this invisible point. And that is key to kind of keep in mind that our pivot is where these actions are happening from. Now, this is where it gets even more tricky, which is when we move around our pivot, which if our pivot gets off, we can go right here to modify, center pivot. But since this is a very key thing right here that we do on a lot of our objects, right next to our friend delete history, we have our center pivot icon. Now, we will get to how you move your pivot in due time. But first, before we can start talking about moving around our pivot, we have to talk about orientation. All right, so when we actually have our pivot, that's where all the movements are happening, and they are based off of orientation, which the X, Y, and Z. So everybody remembers X, Y, and Z. That's how the coordinates of our 3D environment works. Yes and no. It actually changes based on how you look at it. So when we have everything observing the same X, Y, and Z. So right now, if I select all my objects, they will observe Y the same direction as each other, and then X is the same way, and Z is the same way. Same way that me, you, and everybody who's online right now viewing this, and we may be in different parts of the country, we still view magnetic north in the same position. If I asked you where magnetic north or where north is, everybody would probably point to the same location. That is what we call inside Maya global/world orientation, which means if I go right here, no matter what, if I hit W on my keyboard, Y is always Y. on all my objects. If they're set to global, it will always match the world's X, Y, and Z coordinates. But let's go right here and tilt this. Let's say this is in a different location in the world. As you can see, global is still the same. But if I hold down W and left mouse click, what if I changed it from world to object? And what is occurring is, instead of us observing magnetic north or the North Pole, where that is, instead, how about I ask you something a little bit more figurative, where I'm in Florida and somebody's in Australia. We probably, when we say, all right, look directly up, we're probably looking up at different angles. And that's the same way. Local/object is orientation based on how that object perceives X, Y, and Z. Which now, since I tilted it, its Y is now staying with the object. So if I turn it right here, see how now the Y is still following along and twisting with the object. So again, global is how everything views X, Y, and Z based on the 3D environment's X, Y, and Z coordinates. Local is based on how the individual objects view X, Y, and Z, which can change. Now, knowing the difference between these can help you make better selections and movements. Now, we can always change these pivots by doing two things. One, we can either hold down either W, E, or R, hold them down and left click, any one of those, and then we can make our changes right here. Likewise, if we go over here, we can double click on the icon for that tool and make those changes as well too. By double clicking on this, we can get to its settings. And here we can change it from object to world. We can also change other things. So definitely worth like peeking in here and peering around. But that is our orientation. Now, with that said, now it's time to actually talk about how we can efficiently move stuff. Well, you can reset it by, yes, either going right here, double clicking on it and hitting reset. You can also reset the tool to take it back to normal, or you can go right here and hit center pivot. Now, let's talk about the reason why we're here in this scene. So, going back to my analogy from Wednesday, which is we take so much for granted in our real world that it can be hard and cumbersome to manipulate stuff in our fake 3D world, which is if I want to stack blocks in real world, I just pick up a block, stack them on top of each other. They don't go through each other. They don't pass through each other. They have gravity. They have weight. They have mass. We don't have any of that crap in our fake 3D world. So how do we efficiently move stuff around? Well, we can do that with with two methods. First, our ability to change the pivot, which is where the object moves. So let's say if I wanted this to sit on top of here, well, I can use snapping. Well, actually, no, we can move around our pivot by holding down D. Actually, I did this backwards. I wanted to show snapping before I started talking about moving around the pivot. So let's put pivot on the back burner. And let's go back and say, all right, cool. Instead of me eyeballing and moving stuff around, what we can do is, if we remember from Unreal, as you move stuff around, it kind of like popped around to different locations. That's because by default, Unreal has snapping turned on. Maya does not. And snapping is a way to move our objects based on certain milestones. To do that, our first milestone that we're going to move around is going to be vertexes. We can actually have this move and lock to vertexes. And to do that, I'm going to hold down V as in Victor, V as in Victor. And then when I do that, you will see our square turns from a square to a circle, which means now it is locking on to that vertex mode. So now when I start moving around using my manipulators, it is now snapping to where vertexes are. Now I can constrain it by either selecting the 1 dimension or the 2 dimension, or I can flat out like snap it completely by just grabbing our middle and unlocking all 3 dimensions. So now it is really snapping around. Again, this is holding down V as in Victor, and then just grabbing the axis that I want to align in or snap in. So I can either do it in 1 dimension, 2 dimensions, or 3 dimensions, and it will snap to that object. So that is V as in Victor. Next is we can also use our grid as a milestone of where to snap to. So instead of holding down V as in Victor, I can hold down X. And with X held down, I can start moving around and it will start snapping where it makes the intersection on our grid. So holding down X and move that around. Last but not least, the final catch-all, which is C. So if we look on our keyboard, we have X, and then we also have B. Well, right in the middle of them is the C key, as in cat. This will snap to curves, will snap to edges. Pretty much anything that is not a vertex or a grid, C will snap to. So it's our last little catch-all. Now, let's say we wanted this little purple cube to sit on top of that blue cube. Well, let's go right here. This one's way off to the side, so it needs its pivot centered back onto it. So with this selected, I'm gonna go right here and hit center pivot. That will center my pivot onto that object center. But using what we just learned, if I hold down V, you would think I could probably snap that to there. So if I move that around, I'm snapping, but it's still colliding through. So first thing that we need to keep in mind, snapping is one thing. And then we remember that D allows us to move around our pivot. So now that we know that both of those are separate things, we can start using them at the same time, which is, let's say I want the bottom of that purple cube to sit on top of that blue weird cube. Since when I snap, it snaps the pivot, not the object, where should my pivot probably be? If I wanted the bottom of that purple cube to sit on top of that blue cube, where should my pivot be? In one of the corners, yes. So if we go right here, I would say it would probably be best if it was at the bottom of the cube. Well, what visual milestone, what like a vertex, grid, or C key, which one of those are at the bottom of our cube? What? Yeah, that green one right there. So what, is there a component or anything that we use for snapping? Is there anything down there that we could probably snap our pivot to? So if we remember vertexes, so if we look at the bottom, we have some vertex there. So logically, we can use D as in dog to move around our pivot. But if I hold down D as in dog, and then hold down V as in Victor at the same time, I can snap this pivot to the bottom vert right there. So now that means that that pivot is at the bottom. So when I go to snap this to here, Now all I need to do is hold down V as in vertex, move that over. And now, since the pivot was snapped to the bottom of my cube to one of its bottom vertexes, it now aligns itself to the top vertex of this blue cube, or this blue thing. That's not a cube, it's elongated something. It's an arch. So again, we just look at what needs to be moved. So if we are trying to match this to this, which that's the point of our exercise, is to make these look like this. So if I grab this purple cube, center its pivot, where should I snap the pivot of this cube to? So that way it connects up to the top of these right here. Yes, bottom right vertex or bottom left vertex, either one's perfectly fine, just as long as we get like one of these bottom two right here. And again, I'm holding down D as in dog to activate and be able to move around my pivot. And then I'm holding down V as in vertex, so that way I can snap. Now, one of the things that I am missing right here, which is the fact that I need this to actually be in the same position as this right here. So our blue cube is a little bit off. I need to get this to not only be in the same position as this, but it's also sitting on top of the grid. So this is our chance to hold down D as in dog, V as in Victor, and snap it to this corner. Now, when we're snapping, there's two ways to snap. And it will take some practice, and it will take just kind of getting your muscles used to it. First, to snap the grid, I'm going to hold down X, but I can go right here, and I can grab the handle and move it around, and it will snap that way. That is, if all else fails, we can always do that right there. Another way is if I hold down one of my snapping hotkeys, which is, again, either X, C, or V. If I hold them down, I can middle mouse click and drag and wiggle. Very, very professional term there, wiggle. Wiggle over where I want to snap to. So if I want to snap over here, I'm now on middle mouse click and wiggle over where it is. Now, I have it currently locked to this axis. So if I go right here and unlock it and make it all three axes, when I hold down X and middle mouse click and drag and wiggle over where I want to snap to, notice how it hops automatically to where it needs to be. But in this case, I'm gonna go right here. I'm gonna hit X, move that down. And then I am going to hold down V as in Victor and push this over so that way it aligns with that blue one right there. So now they're in the same position. And now I'm gonna go grab this one. Actually, I'm gonna grab this one since it's already kind of set up and go through the same process. I'm gonna hold down B, since now I want the bottom of this to align with the top of this right here, which there is a top vert, and just drag that over. You middle mouse click and drag over where you want it to pop to. So middle mouse click and wiggle over, but make sure that you have the hotkey for the milestone or landmark that you're trying to get the snap to. So in this case right here, I want this vertex to align with this vertex right here. So if I hold down V, pick which axes I want it to move in. So I want to move in all three since I want to hop all the way over there. And then I'm gonna hold down middle mouse click and drag while I'm still holding down the B key. And I'm gonna middle mouse click and drag and wiggle over that vertex. And then I'm going to rinse and repeat. So we're seeing this one right here is aligning to that top corner right there. So that means that this needs to have its pivot snap to here. So holding down D as in dog, V as in Victor. So I'm holding down the hotkey to move around my pivot, and then holding down the hotkey to snap to pivot vertex. I'm going to make sure that I have it unlocked in all 3 axes. And then middle mouse click and drag over that vertex. Click, drag, and wiggle. Just wiggle. Always be sure. And then I'm going to let go of D because I moved my pivot. So now I can hold down just V and middle mouse click and drag over this right here. Our pivot's really off. So again, I'll hit center pivot. And then hold down D and V. How do you set up your Wacom tablet? That we do have a video on Discord inside the 3DF announcements, I believe. And then also you can definitely hop in the lab and you can get assistance there. And we're just going to snap that to right there. Same thing, we're again looking at where stuff needs to align, where they need to be connected. That's a good indicator of where we need to put the pivot. So if we look right here, it looks like we need to have our pivot somewhere in these 2 vertexes. So if I go ahead and select this, I'm going to hold down D as in dog, make sure that I have it unlocked in all 3 axes. Now, I don't have to always do that. If I want to, I can just drag it in one axis, D and V. But it does save time to kind of just yank it over there. Then I'm going to hold down V as in vertex, snap it to right there. All right, let me grab that one last cube. I'll hold down D as dog, V as Victor, move that to that corner. And then we're gonna go right here. And then I'm gonna hold down V as in vertex, and then move that to right there. Now we have this red one. Now we see that this red one is not in the right direction. So we need to turn it, but I don't want to eyeball this. So if we remember from our primitive and talking about these channel boxes, I can go in here and just type in the number that I want it to turn around. Remember, it's based off of 360 degrees. If I type in 360 degrees, well, it won't look like it moved, but as far as mine is concerned, it's been turned completely around. But it looks like I just need to turn it a quarter of the way around. So that means I need to just type in like 90. But the problem is that if we look right here, we have all these random numbers that I don't want to have to do math, even though it's not going to be hard math. It's 90 minus 90. But let's say this has like all these rare, weird numbers. This is what we call transforms. Now, just to let you know, that is how animation works. It looks at frame 1, sees its position using the transforms in the channel box, and then it looks at frame 10 and it sees the difference between the transforms. That's how it actually adds movement. But when we're modeling, those transforms can be a pain in the butt. So we can actually freeze those transforms to where they go back to nice 0, 0, 0, 0, 1, 1, 1. Make our life a little bit easier. And to do that, we can select the object, go to modify, and go to freeze transforms. Or we get to that last one of the cardinal cleanups right there. So we did center pivot. We showed you how to delete history. The last one is that freeze transforms. So now when we freeze transforms, gives us nice clean numbers. So now I'm going to just turn this a little bit to see which direction, whether it's going the positive or negative. And I can see that it's starting going the positive, so I can just type in that 90. And we're all lined up. Now, these are not like just fun little facts right there. These are main parts of what we call professionalism, which we will hammer professionalism in more on the week that we get back. But this is important because this is part of cleaning up our models, making sure that they're nice and ready to go into the next part of our pipeline. Again, center pivot, delete history, freeze transforms. I'm having a hard time seeing this window is pretty small. So how can I make this bigger? What? We can hit F. That will frame up. But how do I make this actual viewport bigger? Yep, spacebar. So tapping the spacebar will pop and allow me to jump between windows. All right, so now we got that right there. I'm gonna hold down D and V to move this to right here. And now I can hold down just V and snap that to right there. And then last but not least, I'm gonna just select I think even Zoom needs a spring summer break. Oh man, this is getting ridiculous. All right, so I just got a huge window saying, hey, everything just crashed. All right, so we're back at it. I'm gonna go right here, and since I already know that all these pivots are wrong, I'm just gonna go right here and delete freeze transforms and center my pivots. And I'm going to make sure that I'm still recording. All right, good. We're still recording. It's summer break. It's summer break. Right, and in Florida, we never really get a spring or a fall or a winter. All right, and then we're just gonna move these pivots right here. And last but not least, move that to right there. And move that pivot to right there. And last but not least, we're just going to move that to right here. And now we completely recreated that. Yes, I know if you want to cheat the system, you can just go and duplicate the other one, move it over. But the main thing is that this is one of the few lecture activities that I would say that until you get good at moving stuff around, this and the Mr. Potato Head, you should try to make a ritual for like the first few weeks to do those daily and time yourself and see how fast you can do that. Because the sooner you can get used to move around your camera, moving around objects, and using the hotkeys for translate, rotate, and scale, and then also getting used to snapping. It's going to make a world of difference when you go into other projects. So this right here and the Mr. Potato Head are like two projects I would say try to do them daily, especially if you're going on spring break. I know it sounds terrible. I want y'all to have fun. I want y'all to relax, but at least try to do these two assignments multiple times, just so you can build up that muscle memory. Because here's the thing, the more that we can induct into muscle memory, the more brain energy and forethought and the ability to do that 4D chess can be spent on trying to model and get certain details going. If you're not having to spend like, processing power inside your brain on having to remember how to move a camera or what is the hotkey for like move, it frees up all that energy to apply to, hey, how do I model this object? What tool would be best for this right here? So with that said, let's go ahead, and that is our first lecture activity. So let's go ahead and take a screenshot. So we introduced the channel box layer editor at the top right here. We introduced this part, but now let's talk about this part right here, which is our layers. Our layers are a way to organize what we see. Right now we have two layers. First is example, and next is text. Each one of these have 3 little boxes next to them. The first box is our visibility box. If I go right here and click B, you can see how it will trigger that to be visible, not visible, visible, not visible. From there, we have whether or not it's visible in like animations. We're not going to worry about that. But next to that, we have the ability to turn it from template to reference to blank. And what that means is that when we turn to template, it makes it wireframe and makes it unselectable. This is important because occasionally you will have stuff that you will need to have a visual footprint, but you don't want to accidentally select it all the time. And you don't also want it to spend extra power doing the shaded mode. Next to that, we have what we call reference mode, R, which we can see it shaded mode, but it is not selectable. Now, this is important to know because I'm kind of spoon feeding you some of the stuff that you need to know for your competency. So we are not going to get to how we add and create layers just yet. We'll say that for the end of the lecture, but we can turn off visibility, which is important because I do not need to see that text. Go ahead, turn that text off for our screenshot. Next, we need to make sure that we have this set up in the proper layout for our submission. So we're going to do something a little different. First, we're going to read. We're going to read the guidelines. First, Maya needs to be maximized and it needs to be in 4-panel mode. All right, let's go ahead and set this to 4-panel. All right, needs to be framed up and easily visible in all of them. So I can see it here, I can see it here, and I can see it clearly here. Now, notice how I'm spending the time to make sure it's framed up on all of these in all the windows. All right, so that meets that first standard. Let's go ahead and look at the next one. Next, it needs to have wireframe on shaded turned on. What is wireframe on shaded? Well, it's a hybrid view, which is it shows our wireframe on top of the shaded object. That's not going to be one of our numbers here at the top. Instead, we need to go right here and trigger it by going into shading and turning on wireframe on shaded. As we can see, it's already turned on in this view. And we can also see that the hotkey is Alt-5. So I'm going to go right here, hit Alt-5. If you're on the Mac, it's going to be Option-5. All right. And then last but not least, we need to take a screenshot. On Windows, I'm going to use the snipping tool. And select the entire program. So all of it. So to make sure that you get full credit on this, 1, obviously you have to do the assignment. 2, it needs to be in 4-panel view. 3, it needs to have wireframe on shaded turned on in all of the viewports. And we need to be framed up on all the viewports. Lastly, the screenshot has to be of all the program, not cropped in of just the blocks. It needs to be of the entire program. I would just say maximize the program and then take a screenshot of the entire screen. That's why I typically tell y'all on Mac, use Command-Shift-3 option because that takes a screenshot of your screen instead of Command-Shift-4, which gives you the option to crop stuff out. But that's me. All right. So with that said, let's go right here, save as. And we're going to name this last name underscore first name underscore snapping. Now, let you know, little secret, if you turn this in properly, we're not going to see how you named it. So you don't have to name it exactly like us. You just need to make sure that you turn it in the right location, which is making sure that you hit this icon, the image icon, and then use that to submit. Now, I did get questions on Do we need to do them, turn them in all at once, or can we do them one at a time? You can do either. Which one is convenient for you? Just make sure that you're uploading it the proper way. All right, and with that, that is our snapping exercise. So any questions about that? All right. So we're gonna go right here. I'm gonna hit File, New. Go ahead and clear that out. And let's go ahead and grab our second lecture activity. How did I move both green at once? I'm not sure what's being asked on that one right there. So with that, let's go ahead and grab the shaping out. And show in folder. I'm gonna extract that here. The two blocks, I just selected both. Can you rotate and snap? Yes, you can use snapping on rotate and scale, but typically a lot more people use it on transform. But yeah, you can definitely experiment with that and see what kind of results. As far as moving the two blocks at the same time, I probably just selected them both at the same time. And then just move them. All right, extract all. All right, and then grab that shaping out. So I'm gonna hit Control Copy. Go to my documents, 3DF, and I'm gonna paste this into my lecture 2. And let's go ahead and set our project and get that loaded up. So right here, I'll go ahead and close that. File, open. Set project. We're gonna set it to our shaping out and hit set. I think I did the wrong one. All right, so set project. Don't like how it constantly hops over there, but let's go right here and shaping out. Oh, that's because it did that zipping thing where like unzip the folder and put the folder within the folder, that Russian nesting doll thing. So now this should be the right one. Hit set and hit scenes and hit shaping out. Don't save. All right. Now, this is one of the key ones that you have to make sure that you are setting your project correctly, or you will not get these images. You'll just get like little boxes with X's in them. If you see that, then you set your project improperly. Just retry the steps and you should be able to get those back up. Now, with that said, let's talk about shaping and manipulating our components, because that is our next level. So far, everything that we've done has been on the object mode level, which means when we move stuff around, really all we can do is, honestly, when we make a cube, all we can do is make a scaled cube or rotate the cube or move the cube, but we're not dynamically changing the shape, the silhouette. We may make it a little bit skewed or anything like that, but there's a limitation of what we can do with object mode. So if we're looking at these images right here and looking at the funky shapes that they're doing, these are not shapes that can be achieved by object mode alone. This is where we have to start looking at our shape and seeing where we need to start drilling in and going deeper. That means going to the component level and moving them. So if I go right here and go into my 4-panel view by clicking over here, we can already see how these are lining up to our different objects. So this is what we would refer to as image planes and reference that we would actually want to match up. Now, these are very basic shapes, but we want to make sure that they are matching up with their references on either side. So I'm having a hard time seeing the reference. So what should I do? 4. Yep. 4. So that way we can kind of see what's going on. Now, if we select this right here, we can already see that this one when we have it selected, which if I hit W, I can pop between 4 and 5. We can see that for the most part, it's already matching up. So this is about the level of what we can do with these shapes right here. So our cube, all it can do is make a different size cube. But what happens when we have a shape like this, where on one side, it looks like a cube, while on the other side, it looks like the Black Widow symbol. All right. How do we go back by and adjust that? Well, we can't go right here and scale it to match that. We can't rotate it to match it. So we've hit the limitation of what we can do with object mode. So with that said, what component or what things can I actually go to start making this shape? And to make this a little bit easier to see, I'm going to hit 5, and then I'm going to turn on something called X-ray. X-ray will let me see through my object, but keep a little bit of that shaded look. But if I wanted to make this shape, what would I go about doing? So somebody's saying add an edge loop, but we already have one right here. I can see that it's an edge loop by going right here, going to edge, and selecting that, and it goes all the way around. All right, I can grab, get the edge, but what can I do with the edge? Well, I can already see that this has that dent in, and I know when I move around the edge, it will affect that edge and the vertex that are attached to it. So I can select that. And again, Maya is one of those things that you can do the same thing 100 different ways. So I can grab that one edge and move it. I can grab the entire edge loop by double clicking on it. And if I wanted this shape to look this way, what could I do with that entire edge loop selected? Actually, Brandon just hit it. Instead of grabbing opposite edges, I can grab the whole entire edge loop. But when I go to scale, I just scale it in one dimension. So now we're just on scale. Match that up. But instead of edges, what else could I probably have grabbed? Instead, if edges worked, what else could work? Vertexes, exactly. So remember that it's a upside down triangle for a reason. If I can do it with faces, that means I can do it with edges and vertexes. If I can do it with edges, that means I can do it with vertexes as well too. I will tell you honestly, I 9 times out of 10 go directly to the vertexes because it does allow for a lot of fine tuning. Go right here and really match up that shape. Go right here, match that up, match these up. Again, I'm just marquee selecting these. And then I can just grab marquee select that vertex, which means it selects the one in the front and in the back, and move that over. And then I can marquee select these vertexes, which means it gets the one in the front and the back, and move those over. Now, I could have definitely did that with the edges as well too. It's just your personal preference. Just remember that it's an upside down triangle. If you can do it with one, you can do it with all the ones that are below it. But now that we did that, that is now fitting our shape. All right. So now let's do this one right here. I'll go ahead. And how would I go about doing this shape right here? How do I create another edge loop? We have not got to that yet. So if I was to make this shape with the geometry that's already there, how would I go about doing that? Well, we already know that object mode has already failed us. We can't make this wonky shape without going deeper. So we can probably go right here. and grab the edges and what? Probably scale them out, right? So I'll just go right here and just scale this out. Seemed to work with that one right there. So now I just double click this edge. And again, when you double click one edge, it selects all the edges that it's connected to, forming that edge loop. And now I can go right here and scale this in. All right, so is that looking good? What? Yeah, the top can come down a little bit right here. So I'll just go ahead and move that down. All right, so now it's looking good. Or is it? So does it still look good? No. And this is where it can become an issue for like a lot of students right here. Remember, 4-panel view and being able to hop between the different windows is vital, but it can lead a little bit to tunnel vision, where you're making your adjustments based off of one screen and forgetting that we live in this virtual 3D world, which means we have to make sure that we are maintaining the look and the silhouette in all angles, which means when I went to go scale this, I didn't scale, I skewed, which is when we have something round like this, one of the main reasons why we have it round is because one, curvature is really one of the hardest things for computers to get right. So when we have curvature, we do our damnedest to maintain it. So when we skew it like this right here, we mess up the purpose of that shape. So instead, we need to make sure that we're paying attention to all angles. And instead of skewing it, we scale it. And now it's doing it on both and maintaining that roundness. And then yes, we'll make it a little bit shorter. All right. So if we look right here, same logic. We go right here. And we can already see, like, we have these edge loops in here. We already see that one edge loop is maintaining the shape. It's maintaining that cone shape. And then this edge loop is going to affect the shape, affect the silhouette. So what do we need to do? Scale. All right, so we go right here and start scaling. And oh, something weird is happening. Does something look off? So, something look weird? All right. Are we seeing a different color? What color when we go in component mode? Let's see if anybody has, like, photographic memory. When we've been going in the component mode, what colors have we been seeing? We've been seeing, like, yeah, green or a very bluish green. What are we seeing right now? Yellow. Or it could be yellow. It could be red. It could be black as well too. But the fact is that we're seeing all this multicolor. This will happen. You will freak out. It'll be like 3 o'clock in the morning. This will happen and will prevent you from doing any of your work. All because of one key. That is the B as in boy key. B. The B key is something that we call soft select, which means that it's going to have a little bit more of a fall off when we go to move it, which for modeling, it's pretty awesome. For what you're doing right now, it will be the bane of your existence. So you want to make sure, yeah, no boys. Yeah. B as in brass. If that helps, I don't know. I always like mind fart when it comes to like, trying to come up words that like begin with the letter. But when we see it go multicolor like that, you want to make sure that you hit B as in brass or bucket, and that will turn it off, allowing you to go back to your happy life of making nice shapes. And then last but not least, so if you happen to be on the Discord and you see somebody, freaking out because they can't move anything, and you see that change of color, save a life. Tell them to press the B key and turn it off. All right. Last but not least, let's go ahead and make this shape right here. So same thing like we've been doing, which is scaling. But how can we save ourselves some steps? How can I do these both at the same time? Let's have like a little brain teaser. So if I select both this and this, we already know that probably we're going to scale. But which way? How should we scale? Well, if we use the 3 dimensions, see what happens. That's not good. So is there another way we could scale? Yes, somebody just hit it right there. The green square. And do in 2 dimensions. That pesky y is what's screwing us up. So if we take the y out of the equation by doing only 2 dimensions in the x and z, we can do both at the same time. Looking good. And now we harness the power of translating, rotating, and scaling, not only in object mode, but now we're harnessing the power of being able to do that on the component level. Anything that is worth making, well, you will not be able to get to unless you start understanding how we have to go into this components and actually moving them around to affect the shape. Now, with that said, let's go ahead and take a screenshot. So like the last time, I don't need the text. I know what it says. I don't need to see it again. So we're gonna go right here. Make sure that everything is in object mode. So I'll just right click, go to object mode. I'm gonna make sure that X-ray is turned off in all of these. All right. Nice frame up on all of these. Nice frame up on all of these. And then we're going to just go right here. Alt 5 or Mac Option 5 and turn on wireframe on shaded on all of them. I'm going to double check to make sure that is exactly what I told you to do, which is, maximize, set to 4-panel view. Set the models to wireframe on shaded, make sure that they're all easily viewable, and make sure that the screenshot is of the entire Maya program. So from here, we're going to go to snipping tool. I need to actually probably pin this to the taskbar. Pin the taskbar. Oh, there you go. Nope. And then file, save as. And we're going to name this shaping up. Chapping up. All right, there we go. All right. Now, last but not least, let's start making some actual cool objects. Now, what we're about to get into is going to be almost like a trainer for what we're going to be doing for competency 1, which we'll talk about your competency 1 after we get this next lecture activity done. But how we can build these objects, because we're not introducing modeling tools just yet. All right. Instead, we want to get you comfortable with not only assessing an object and picking out the right primitive for it, but also getting into the habit of doing something called blocking out and how we can use that to help us figure out how much geometry we need, how to change the defaults on the primitives, what primitive works best, how many parts. So first, let's talk about what blocking out is. So when you go to draw, do you go immediately to like detailing everything? Hopefully not. That seems really hard, especially if you make a mistake, then you did the hardest part first. Instead, you sketch it out, you plan it out. It's the same way with modeling. We don't go immediately to detailing Optimus Prime. I think it's always funny. I always go to Transformers, even though there hasn't been a Transformer movie in like 8 years. But anyway, but the fact is that we have to plan this stuff out. So that's where we get into something called blocking out, which the goal is to break our object down to their basic shapes. So I always make the joke of like, if I was to make a crate or a barrel or a basketball, what shapes would I start with? All right, well, obviously box for a cube for the crate, a cylinder for the barrel, and then a sphere for the ball. Those are give-me's. But if we were like looking at like a chair, what would we start with? Well, it depends on what the chair looks like and how it's constructed. That helps us make intelligent decisions on which parts to start with, because picking the right primitive can shave hours off of our time. Next is it gives us a chance to break stuff down in pieces. All right, look at everything around us. Not everything is sculpted out of one piece. Like when you got your Mac, it wasn't like carved out of one huge block of aluminum. It's a bunch of different pieces manufactured together. Look at your chair. It's built into different pieces. We have to emulate that in 3D as well too, because when we build stuff in pieces, it lights more accurately, it textures more accurately, and we can animate it more accurately. Another reason why we build stuff in pieces is because it's way easier. Instead of me having to worry about all those edges flowing into each other, if I had edges that made the tabletop and they were flowing into the legs, that can disrupt and make stuff even more complicated. Because when it comes to edges, the more that you have, the more issues and more problems that you're going to have with them. So if we can localize those edges to where they're only needed in the areas that on the different parts, we can make our lives easier. Okay, so with that said, let's go right here and let's load up our last lecture activity. So if we go right here, we're gonna go ahead and grab that blocking out shapes and show in folder. Blocking out shapes. And I'm just gonna drag this into downloads. Just save a step. Hit Control C. Documents, 3DF, week 1, lecture 2, and Control V. All right, so we're gonna go right here and load up Maya. Load up. So file, new. Don't save. File open. As always, it pops to the wrong screen. All right, so shaping out, we're actually going to go right here, set project. We definitely need to make sure, well, we always need to make sure that we set our project correctly, but we definitely need to do it on the ones that have the images, because this is going to have images. We're going to hit set. And we're going to go right here to scenes, blocking out shapes, don't save. All right, continue. All right, so what we're going to do is actually build out these objects. We're going to look at the reference and assess what they are, and use some common sense with it as well too. But each one of these, not only do they have their shapes, but each one is broken down to their different parts. Different colors means that it's a different part. So we're going to go through the process of blocking this out. So the first one that we're going to start with is going to be the pencil. So what shape should we start with the pencil? You say cylinder? Yeah. Some people say cylinder. Some people say pyramid or cone or something like that right there. And it really depends on what you think is the main focal point of it right there, which is sometimes it can be easier to start with the hardest part first, which is probably, the tip of the pencil and moving up. or we can go with the part of the object that is the most consistent, which is the roundness of that pencil. Now, a lot of people will try to make the pencil out of a cube. Don't do that. You will not get credit. But let's go right here and let's start shaping this out. So first thing that we want to do is navigate to our different windows. And again, I'm just hitting the space bar to get closer and pop up these windows. But let's go ahead and I'm going to go to polygon modeling and I'm going to hit cylinder. So we're going to move that into place. Same way that we did with our Mr. Potato Head. We're just going to get that in position. And I'm going to use my 2D. Actually, I'm going to go right here. Hit W, move this over. And now I'm going to use my 2D scale to scale this thinner. And then I'm going to go right here. And like I said, I always like to make adjustments with vertexes. You may choose to do opposite. That's fine. But vertexes work good for me. So I'm going to just pull this all the way up. And all the way down. Does it have to be exact? It just needs to be close enough. Because even if you look right here, our reference doesn't line up 100% either. So I'm going to probably pick a main one to focus on, but we want to just get close enough. All right. So with that said, now let's start going about doing the pencil. So, well, we could probably do the pencil by going right here and maybe going to that point right there. And then how would we probably form the rest of that pencil, like the bottom? Yep, just grab that middle point right there. So if we look right here, since this is all yellow, this all has to be one piece. So we have to keep it one piece. So we can just now just grab that one vert and just bring that down. We can utilize the geometry that's already there. All right. So for the most part, we got that built, except for these come out a little bit right here. So we need more geometry. So if we go right here, since we got a cylinder, let's try to go ahead and change and add some more subdivisions along the height. So this is considered a height. So if we go right here and start adding some more subdivisions, ooh, what's going on? Yeah, it has that history. It's already been modified too much. So I cannot make those changes anymore. Preferably, I should have looked at my pencil and strategized a little bit more. But at your current situation, this sounds mean. Y'all don't know enough to strategize. All right, that's going to happen. The only way that you can strategize is that you know enough to strategize with. So what do you do in this situation where you've already started modeling, but you need those extra edge loops? Well, let's go ahead and Z back. So if we clear history, it will remove that option as well too. It will lock this in, so we still will not be able to do it. So preferably, if you can, look at your object and try to assess whenever possible where you can change the default settings on it and manipulate it that way. But if we run into a point where we've already started modeling and we need to add in edge loops, this is where we will introduce our first and only tool. Well, actually, we're going to show you two tools, but they're the polar opposite of each other. All right. One undoes the other. But the one tool that you're going to be able to use on your competency is going to be your mesh tools and insert edge loop tool. Mesh tools, insert edge loop tool. And what this will allow you to do is to click on the surface. So you want to click on the edge that you want to go across. So if I click on this edge right here, it will draw an edge loop all the way around. What? Yep. So again, we can click on the edge and it will drop in a new edge loop. Click on the edge and it will drop in a new edge loop. Now, with that there, how do we remove an edge loop? Now we could hit Z back, but let's say we've been doing some stuff and we realized a little bit later, way past where we can actually undo, how do we remove an edge loop? Well, people would think that if you have it selected, you can just hit delete, right? Don't need that edge loop, hit delete, right? The problem is that when we hit delete on our edge loop, it's very literal, by which it means it'll delete the edges, but what did it leave behind? Yep, the vertexes right there. Which, when we have more than 4 vertexes on a face, what problem geometry does that create? Creates a n-gon because it's no longer 4-sided. It adds more edges, and that means now Maya doesn't know the direction on the surface, which means now you can no longer use the insert edge loop tool on this surface. It's broken. So how do we properly remove an edge loop? To properly remove an edge loop, we need to select it, and we can either go right here to edit mesh, delete edge, or if we look off to the side, we can see that it's control delete. So if we go right here and hold down control and hit delete, now it deletes the edge and the vertexes, and we maintain those 4-sided faces, which means now we can still use our insert edge loop tool because we're going to need a few more. So, and we'll show insert edge loop tool and delete edge tool a couple more times on these other objects. But the fact is that those are the only 2 tools that you are allowed to use on your competency, which really all there are is insert edge loop tool and a way to remove the insert edge loop. But now we have this surface. So we have a change in surface. So if we remember, our edge loops serve 2 purposes: to maintain the shape and to change it, which means we need an edge right here to maintain the surface. And then we need another one to change it. So we need one right here. Scale that out. Now, if I have a tool in hand, I can always click it back on by clicking over here. So since that was the last tool I used, I can just click right here. Or I can hit the hotkey G as in group. G as in group, and that will bring back or redo my last command. That right there. Hit R to scale. Scale it out uniformly. And now, behold, a pencil. Make our life a little bit better. As you can see, as we've been doing all our different modes of modeling, we have developed quite a train of stuff on our objects. Forgot how you expand this out. There we go. Pretty much it's like a whole bunch of like different like math going through. So typically, once we're happy with something, it's good to center its pivot, delete our history, freeze our transforms. Now, let's move on to the next one. So we got a chair. Let's look at our chair. So if we were to look at our chair, specifically wanting to do the legs, what shape should we start with? A cube? Yeah, pretty basic. So I'm gonna go right here, hit the cube. Come on, cubey. And I'll just bring that over. Bring it over. And I like to size up by going to vertexes. Again, you can do this with faces. You can do this with edges. You can do it with vertexes. Or you can keep it in object mode since we're not changing the fundamental shape. Whichever makes more sense to you, experiment and see which one is the fastest way for you. But I like to kind of fine tune this. Just bring that over. Again, notice how I'm marquee selecting over these areas right here. So that way it selects the front and the back. Why not a cylinder? Because, you know, I want it to be a cube. That's how I've always thought about it. But now that you say it, like, you know, cylinders could work. But let's keep it a cube. But yeah, I guess it all comes down to perspective. But yeah, right here. Now we have this leg built. How would you go about building this leg? Duplicate, exactly. Save yourself some time. We are living in a digital medium, which means we can duplicate, move it over. Same way with right here. I can select both of these and then hold down Shift and pull that over. So now we have 4 legs. Now, how about this seat? That's exactly what I would do. So what our student here said was just duplicate the leg, bring it back up. So whatever keeps my cursor close to the model, whatever I can come up with solutions, that makes me faster. So instead of me constantly have to go, hey, give me another cube, give me another cube. Instead, let's go ahead, duplicate out another cube. And this time I'm gonna hold down D and V to snap my pivot to the bottom right here. And then hold down just V and snap it down. So that way it's aligning. So where it's sitting on top of the surface right here. Now, I accidentally made 2. That's fine. I'm just gonna go right there, get rid of that one. And then I'm just going to correct the size. And this is something I like to do. When we're blocking out, I literally kind of try to build off of what's already there. Now we're sizing up. All right, so we got these back 2 rails. So how would I go about doing that? Well, I'll probably just grab these. But this time I'm just going to hold down D and V on both of them, because here's the cool thing. Our pivots will move in relationship to the local orientation, which means if I snap this to the corner, it will snap the pivot for this one right here. Actually, before, yeah. Actually, nope, it's snap both of them to the same one right there. I forgot which one actually, I have to remember. You can actually keep them separate and have them go to their own individual corners. But for this point right here, I'm just gonna actually go and rewind and just go right here. I'm gonna just select one and move that pivot to right there. And then hold down Shift, scale that up right there. So that way I can hold down V and snap it to the top of here. And again, we're just building off of the surfaces that we already have. And again, I'm going right here to vertex mode. And I'm trying to slow down like some of my movements, because here's the thing. Muscle memory, I'm not joking. If you get used to muscle memory, you don't even have to pay attention to where these are right here. You just make the motions and it will actually make the selection. So instead of me constantly hitting right click and then going and reading where edge is and going up, 9 times out of 10, I'm just going like right click and dragging up really quick. And now I'm in edge. And that's what is called a marquee menu. Marquee menus use muscle reflexes. Same way, like if we have any fighting game players, you know, you don't have to think about the combos anymore. You have that in your muscle memory. And the more you can add in muscle memory, the more you can just strategize. Last but not least, I'm gonna go right here, do the same thing. I'm gonna copy one of these, hold down shift, move that off to the side. But since it's already in the corner right there, I'm gonna hold down V, drag it to where it aligns with that one board. Right click, go to vertexes, select that. Select this up. And then move this over. And now we have chair. All right. So can you move the taps around? Not sure what you're asking about that. But with that said, let's go ahead and start moving on the mailbox. So let's first start with the legs. So for the legs, how we want to make those? Yeah, we can copy a lot of the legs. Just grab these legs, select all of them, and yeah, just move them over. Just going to move right here. Oop. Modeling is all about working smart, not hard. Now I would show you like a little bit of a trick right here, which is one, since most of y'all are on the Macs, I need to stress to you the importance of your function keys, which is the F keys that are at the top, which for some reason they decide to replace with the touchscreen and not have them all the time active. But right now we have these all in object mode. Now, one of the things that we can do to help us get them to the right size is I can go right here, hold down D and V, move my pivot all to the corner, and then just scale them down. Another thing that I can do is I can put them all into vertex mode or component mode by holding down the FN key on my keyboard. So FN, and then pressing F8. And that will turn them all into component mode, allow me to grab all the vertexes and pulling them down. Now, that's more of an advanced technique, but just that gave me a chance to not only show you how to put them all in component mode at the same time and be able to adjust them all at the same time, because usually when we go into component mode, it's usually per object. We can't usually do multiple at the same time. But this is a chance to show you F8 and then also make you aware of the function keys on your keyboard because they do have a purpose inside Maya. All right. Now we have that done. Let's go ahead and let's do our mailbox. So for our mailbox, what shape should we do? Keep in mind, it's blue. It's only one blue color right there. So that means that it's only one shape. We have to make this shape from one object. So you say cube. So one person says cube. Actually, two people say cube. Some people say sphere. We could probably do it with a sphere, but probably wouldn't be the funnest. And somebody's saying cylinder. So this really comes down to your personal preference. Now, not for this project because you have to do it the way that I'm going to do it because I'm going to force you to do a certain different way. But later on, it comes down to personal preference and how you actually break stuff down mentally in your mind. That's why I always say, if you can, always observe other people doing the same thing. By which I mean, ask how Sarah will do it. Ask how Wade will do it. Ask how Brian will do it. Ask anybody in the Discord how they would go about it so you can get different perspectives. So that way you can form your own way because my way may make sense. It may make no sense to you whatsoever. But for me, I like to start with the hardest part first, in which going back to round stuff is very hard with computers. So instead of me worrying about the bottom where it gets very, very cube, which computers are very good at doing straight things, instead I'm going to focus on the round part and start with a cylinder. I'm gonna go right here, make a cylinder. And again, remember, this has to be all one piece. So I'm gonna turn that. I'm gonna type in my 90 degrees to make sure that it's actually perfectly turned. 'Tis one piece, yes. And then what I'm gonna do is get this to where it needs to be. So that's the same width. I'm gonna move my pivot. So I'm gonna hold down D and V and then just pull up so that way my pivot's at the top, which is gonna make it a little bit easier to start kind of scaling this out. Still need to make sure that I'm keeping it the same size. Probably a little bit more. All right, so now I need to form these shapes right here, the shape. So using what we've learned so far, how would I do that? We can't create two edges because we already have enough edges for what we need. So the problem is that our shape is not in the position where they need to be. So when our verts are not where they need to be, then we need to move them to where they need to be. Which means I'm gonna go right here. I'm gonna grab this one and I'm gonna probably say this one. Actually, no, I'll probably do this one and this one. I'm gonna just bring these down. Scale these out to that corner. Then I'm gonna grab these two. Those three, just bring those down. And then that is modeling right there, which is, it's not always one step or a tool that does it for us a lot of times. Another name for modelers are vert pushers, because that's what we're doing, is yanking them down to where they need to be. Now these need to be a little bit flatter. So I'm going to show you a trick to make things flat. If it's in one single line like this right here, we can grab our scale tool and scale it flat. Because if we keep on scaling down to the center, it will hit finally a point to where it hits 0 in scale, which means that it is flat. So now when we look, we can see that our legs are in the wrong position, but we have our mailbox. Now, probably asking, well, is that proper edge flow? Not really, but with the limitations that we're imposing on you, this is perfectly fine. This is to get you thinking about, just because a shape looks like something, we may have to assess different parts, different details to help us determine the proper primitive to start with. All right, so we got that going on. That looks good. And again, we have this and the 4 different shapes. I would probably spread these out a little bit more, keep it a little bit more consistent, but that's just me nitpicking. But that's fine enough. All right. Delete the face and then add an edge loop and then extend it down. Well, the thing is that if we delete a face, then we start opening up our object. So we can't delete any faces at this time. And that's for, this is kind of get you prepared for what you can do on your competency. All right. Last but not least, let's go ahead and knock this one out right here. So if we look at our lamp, we're going to assume that it's all round. So that's a round base. That's a round center part right there for the actual lamp part. And then that's a round shade. So just for the sake of time, we're just going to go right here. And I'm going to make a cylinder. I already know that's a cylinder. And also, I already know that this is going to be one piece, this is going to be one piece, and this is going to be one piece. So I'm going to actually duplicate this out because I know I'm going to use it. So I'm gonna hold down D and V. And actually, technically, I can hold down X as in X-Men and then snap it to the grid. So that way it's actually sitting on the grid. Put that in the right position as well too. Yeah, that's close enough. Hit R. Scale that down. All right, so now that we have that in position, we can already see that there is change in shape that needs to happen. So we already know that we need to use something to bring in edge loops. So that's a good indicator that we need edge loops. So we just need to go right here. And then we're gonna go to Mesh Tools, insert edge loop tool. And like we did with the pencil, we need to, as you can see, this is a little off. So I'm just picking one to stay consistent, but I'm gonna go right here. We need one to maintain the shape and one to change it. So from there, I'm gonna go right here to face, select this, and to get that indent, what should I do? Get that indent, what should I do?
Scale it.
Yeah, scale it, but scale it how?
Is it 2 dimensions?
2 dimensions, yes. And now we're good. I would probably bring this down a little bit. There we go. All right. From there, I'm going to take this and we're just going to snap this. Hold down D and V. Oh. Snap it to that middle vert using D and V, and then just holding down V as in Victor. I'll snap it to the center of there. Again, I'm just wiggling over the vertex that I know that's in the center of right there. And again, you can always just keep on dragging until you get the position that you want. Remember, it's just snapping. And then I'll scale this down. Then I'm going to scale this up. Well, actually, I'm just going to drag this up. And then we're going to repeat the same process. We need an edge to preserve and an edge to change. So I'm going to put one right here, preserve that detail. I'm also going to cap one off right here. We're not going to worry about that bend just yet. But I'm going to go right here. I'm going to grab these faces. And then I'm going to do that 2D scale. Just so that we can get that width right there. All right. And then I'm going to go ahead and add in those edge loops right here so I can change this. So one to preserve, one to change. One to preserve, one to change. And then again, do that 2D scale. Yes, so again, we use one edge loop to preserve the detail. So we want to preserve that roundness right there, but then we need another edge loop right there so we can make that change.
I have a question. I don't mean to interrupt.
What's up?
Isn't it easier to use different shapes to make this, or it has to be all one?
It all has to all be one.
Okay.
Yep. Yeah, when it comes to modeling, you one, you assess whether or not it is in multiple pieces. So if it's actually built in different pieces in real life, then yes, you're going to model it that way. But let's say number one thing that like a lot of people do is for like a handgun for like your props next week. Well, not next week, the week following that right there. What a lot of people will do is instead of modeling the actual pieces, what they'll do is take a bunch of primitives and just hammer them into each other and penetrate them in. And that's not real modeling. And that's what you want to avoid is instead of trying to force the primitives to stack on top of each other to fake complexity, you want to go in there and actually manipulate and add in that complexity onto your objects. All right, so we got these in right here. We got that indent. That's looking close enough. Like this is a little bit off right here, but it's actually pretty close to that right there. But now let's talk about this curvature. The curvature, a lot of people have issues with because what they'll do is they see a curve, so they think, all right, cool, I need to load this up with a bunch of edge loops, and then I can start scaling out. The problem with that is that the second that you add in more and more edge loops, the harder it becomes to make nice, clean changes in curvature. So instead, my way of getting curvature is this. We have it capped off from the top and the bottom. So these are the main declines. So I'd like to place an edge at the apex where the curve comes out the most. And then scale that out. From there, I start looking at my shape again and judging where I need those more edges. So we can see that now this is the main hump of the curve. So I'm gonna put one right there and one right there. And then I just start scaling those out. And I'm only adding edges in as I need them. And then I rinse and repeat. So this one right here, it looks like we need one right here. For me, that honestly looks good enough. I could probably add some more in here. Probably, yeah, let's do 2 more. You know, we're just paying attention to that curvature. And there we go. Again, if we overrun it with edges from the get-go, it becomes harder to actually add in that curvature and kind of keep it consistent. But if we just add them bit by bit as we need them, it becomes manageable. All right, last but not least, we got this lampshade. So everybody knows what a lampshade looks like, right? It's like a little hoop that you place around the light bulb. So it needs to be kind of hollow in the center. So keep in mind what we are allowed to do. We are allowed to move around the object. In object mode, we're allowed to move around the components. We're able to change primitives defaults. We can have a wide range of primitives that we can use. We can use the insert edge loop tool, and we can use the delete edge tool, which is, remember, control delete is the delete edge tool. All right. We cannot use any other tools. We cannot delete part of the surface. So how would we make a lampshade? People are saying cylinder. Cylinder, if I do a cylinder, that may not let light out. So that's just on cover up my light. Somebody's saying cone. The cone is going to run into that same issue. It's going to just cover up the light. Somebody's saying paper, but you got to do a heck of a lot of like bending it to make it round. So this comes down to, if you haven't yet, make every single one of these so you can get an idea of what's there. And if you do, you will learn that there's a cylinder but there's also a pipe, which has an inside. So I'm gonna snap it over here. And then what we want to do is just adjust the defaults. Go right here. I'm gonna make the radius slightly bigger. I'm gonna adjust the height, which I can tweak that a little bit later. But the main part is lampshades are a little bit thinner. So you got that. And again, we were adjusting the defaults by using our middle mouse click and drag. We click on the attributes, but the main thing is that we did that at creation. If we did any other modeling on here, we would lose the ability to change it. But with that right there, we can select all our bad guys right there. Center pivot, delete history, freeze transforms. And now let's get ready for our screenshot. So we're gonna frame up on that. As always, I do not need the text, but the text is not on a layer. So I'm just gonna delete it. And we're just gonna go right here. And frame up. And then I'm gonna go option 5, option 5, option 5, option 5, or alt 5 if you're on Windows. I'm sure more of y'all are on Mac than Windows, even though I'm currently on a Mac that is running Windows. And what we're gonna do is take our screenshot. And this is going to be called save as. Blocking out. Hit save. All right. So everything that we showed today, I know it's a lot of information, but it all is little parts that builds to the whole, which is every bit of the skills that I've shown on Wednesday and today. All of them are vital, not only for you to continue progressing as an artist and a 3D artist and make some really cool stuff, but the skills that I showed this week are going to be necessary for us to do our main project, which is our competency 1, which is shapes and forms. So shapes and forms, let's go ahead and I'm going to grab the shapes and form project. I'm gonna go right here, show in folder. Where did that folder go to? All right, grab this, go to download. I'm gonna drag that into downloads and shapes and forms. Drop in there. Drop in my week 1. All right, so now we're finally where we need to be. All right, so we're gonna go right here. File, open, set project. Week 1. And I'm getting ahead of myself. So set project. We're going to back out right here, make sure that we're going to shapes and forms, hit set. And then now I can open this up. All right. So what shapes and forms is that if you have any experience with 3D, this is probably going to be the most infuriating project for you, because we're going to pretty much strap one hand behind your back. Now, if you're new to 3D, you're probably going to be in a better position because you're going to be entering this with some fresh eyes and understand the limitations that we're going to have, which is for this, each one of these objects are one object each. You're not going to use multiple objects to build one thing. You're going to build it out of one object each. So each one of this, one object, one object, one object, one object. To build them, you're going to use a combination of changing your picking the right primitive, changing the primitive's default settings. You can also use insert edge loop tool and also delete edge as well. But you're also going to be manipulating not only your pivots, but the control components as well. All of these are supposed to be brain teasers. Also, I have me, Brian, Wade, and Sarah. I don't know why I blanked on those names. We are not allowed to provide you step-by-step help on this because this is supposed to make you think. There's no tutorials on this. There is no walkthroughs on this. Instead, this is supposed to show what you understand from week 1. Now, that does not mean that you can't talk to each other on Discord and brainstorm this, because one person may be able to figure out one object, but may be stumped on another one. And you may be vice versa. And it's okay. We want to facilitate that communication. Now, when we say brainstorm, that does not mean share work. Instead, brainstorm your ideas. This is your chance to see how other people think. And maybe their way of thinking makes a little bit more sense. So with that said, this is like a test, yes. This is an actual project. So this is your week 1 competency. So this, along with the lecture activities, have to get done by 11:59 p.m. on Monday, July the 12th. Now, with that said, realize we have 3 levels. Level 1 is going to be the simplest. Level 2, a little bit harder. And level 3 is supposed to be not only kind of tricks, but also going to be the hardest. So in total, you're going to have 12 objects. As you get done with them, so let's say for this one right here, if I was to do my cup, that looks like a cup. As I get done modeling these, you will want to add them to their specific layers. So let's say I'm done with this right here. Now, I'm not actually done with the cup, but if you're an eagle eye from earlier in this lecture, you may have noticed the hint. But as we get done, you need to add these to the layer that they're on. So this right here is a level 1 object. So with this selected, I can add this to the layer by right-clicking on the layer with this selected and add selected. That's going to be part of your professionalism. So all your level 1 stuff need to be on the level 1 layer. All your levels 2 stuff needs to be on level 2. And all your level 3 stuff needs to be on level 3. Again, to add it, you select it, right-click, and add selected. Now, keep in mind, once you add it, it will be kind of unselectable because this is set to reference. If you need to go back and select it again, you need to turn that off. Now, again, to help you, you can brainstorm with each other, but also notice that we left the wireframe on all these objects. So that way you can almost use them as a hint, as a trace to figure out how stuff should be. Also, we provide you with more reference. So if we go right here, that's the wrong window. Documents, 3DF, week 1, shaping week right there. So if we go right here to our source images folder inside the week 1 shape and form, we have even more reference images. So does the wireframe need to be exactly the same as a reference? Yes, if you want 100. All right. So you want to get as close as possible. Also keep in mind, you're not allowed to delete any part of the surface. A lot of people like to make a torus right here and then delete half the torus. Well, that will not get counted. Instead, it needs to always be enclosed objects. Now, we got images for you. Another thing that we have for you to help you is if we go up here to the top, you can click on the Sketchfab link. And this will allow you to, inside your browser, to look at these objects in 3D and get a closer look at them. As you can see, that's a cup. Cup, cup, cup. That is closed off. That right there looks like some type of gear, and so on and so on. So use all these methods to your advantage. Use what you learned this week, and that is your competency. Does anybody have any questions? No, you're good. All right. So again, definitely utilize today's lab as much as possible. Utilize the Discord. Like I said, we're all going on summer break, so don't expect help over the summer break. We prefer for y'all to take that break as well too, so y'all can mentally recharge. If you can, brush up on your skills a little bit right there, so that way they're not getting rusty. But the fact is I hope y'all have a great summer break. Be safe. I will see you when we return on July 12th. Yes, each object is made out of one primitive each. So even that pumpkin, that was one object. When does your summer break start? Technically, I don't know if y'all have art tomorrow. Maybe, I'm not sure. But it definitely starts Sunday. It starts at 5:01 p.m. today for me. So if you have any more questions about that, definitely double check FSO Full Sail 1. They will have the exact number, but yeah, if you don't have class tomorrow, then technically it starts today. So outside of that, y'all take care. Be safe. Anyway, y'all take care.
Thank you.
You're welcome.